Astronomers of Fine Living Ramen. I'm from 21B. Today I'm going to start my presentation with 0.1 Introduction, 1.1 Background. Pandora was founded in 1982 in Copenhagen, Denmark by Per Edvardsen and his wife Vinnie. Its mission is to provide women across the globe with unique and elegant jewelry that celebrates individuality. Its specialty is known globally for its customizable charm bracelet, rings, necklace, and earrings. Focus on high quality, modern. Next is 1.2 Objective, where to analyze the relationship between selected independent variables. The dependent variables using regression analysis evaluate the reliability of the questionnaires used in the study. Next is 2.0 Methodology. 2.1 Question Design and Demographic Variables. 1. Demographic variables is age, gender, race, and job title. 2. Independent variable, customer target, store location, and buying frequency. For 2.2 Data Collection, they have 4 steps, which is create a Google form to collect a customer survey. Number 2 is collect the survey via social media platform. 3rd is collect the survey from the customer via email. Number 4 is share the link to the customer of Pandora. Next is 3.0 Analysis Data. 3.1 Descriptive Statistics, Standard Deviation, Minimum and Maximum. As we all can see, this is the data from Descriptive Statistics. For customer target average, minimum is 1.00 and maximum is 5.00. For standard deviation is 66296. For star location average, minimum is 7.75. Next is independent sample test, which is customer target average is the most lower in equal variance not assumed, which is negative 51566. For the most upper is star location average, which is equal variance not assumed, which is 16306. Next is variable and conclusion. Number 1 is customer target. For male means is 3.77 and for female mean is 3.93. In conclusion, female have the most high perception of the customer target compared to males. Number 2 is store location. For male means is 3.63, for female means is 3.82. In conclusion, female perceive the store location more positively than males on average. Number 3 is buying frequency. Male means is 3.19, female mean is 3.59. In conclusion, females show a high buying frequency compared to males on average. Next is result of independent sample test. The test result. Purpose of the test is to evaluate if the mean differences between two groups are statistically significant. If a value more than 0.05, the difference is not statistically significant. If p-value less than 0.05, the difference is statistically significant. So in this data, all variables have p-value more than 0.05, indicating no significant differences between groups for any variable. Last but not least, for conclusion in standard deviation, through the standard deviation data, it shows that females have slightly higher average score than males for all variables, but the differences are not significant enough to matter at the 0.05 level. That's all from me.
I'm Connie and the matrix number is 241220628. And I'm going to present the normality test of 3 independent variables, which is customer target, store location, and buying frequency. First, I'm going to present the normality test of customer target. In this slide, show that 3 data that we calculated in SPSS. The first one is future plot. Future plot shows that point align closely with the diagonal, indicating approximate normality. Some deviation is visible at the lower end. The next one is the trended future plot. Most of the trended future plot points cluster near the zero line. One clear outlier on the lower end. And last one is box plot. Box plot data is centered around 4. A single outlier is observed below 2. So for the conclusion, the data is generally normal, as evidenced by its close alignment within the future plot diagonal and the clustering near the zero line in the dependent future plot. However, a single outlier at the lower end is notable. The outlier could affect result if it represents noise, for example, data entry error, or uncover meaningful diversion in business. The next one that I'm going to present is store location. So the normal future plot compares data to a theoretical normal distribution. Points on the diagonal line indicate normality, but the diversion suggests non-normality. And the next one is the trended future plot. The trended future plot checks diversion from normality. Points near zero line indicate normality, but the largest diversion suggests non-normality or outlier. And last one is box plot. The box plot summarizes the data distribution and highlight outliers. So for the conclusion, the data future plot shows small diversion from normality, but the box plot shows the data is mostly symmetric with no major outlier. The next one that I'm going to present of normality test is buying frequency. The normal future plot of buying frequency shows data points close to the diagonal line and also suggests approximate normality with minor Q diversion. And next one is the trending future plot. The point cluster around zero line with minor diversion, and it further conforms near normal distribution. And the last one is box plot. The box plot symmetrical data with no extreme outliers and it supports normality assumption. And for the conclusion, the data appears to follow a normal distribution as shown by the triple plot and box plot, which indicates symmetry and no extreme outliers. For the buying frequency average, the null hypothesis that the data is normal is noted. Therefore, parametric tests are suitable. The next one, I'm going to present Pearson correlation. And the first of Pearson correlation is customer target and store location. From this data, we can know that the Pearson correlation of customer target and store location is 0.455 and the p-value is 0.000. Since the p-value is less than 0.05, we reject the null hypothesis. This indicates a statistically significant positive correlation between customer target and store location. The moderate correlation 0.455 suggests that as perception of customer target improve, perception of store location also tend to improve. The last part that I'm going to present is Coon-Batch alpha. In this data, Coon-Batch alpha is 0.668. This value shows moderate reliability. A value between 0.6 and 0.7 is considered acceptable for exploratory research, suggesting that the three items in the scale are reasonably consistent in measuring customer satisfaction. For the null hypothesis, the scale items do not show sufficient reliability, with Coon-Batch alpha being below an acceptable threshold. While the alternative hypothesis, the scale items are reliable, with Coon-Batch alpha meeting or exceeding the acceptable threshold for internal consistency. In this case, since the Coon-Batch alpha is 0.668, we would fail to reject the null hypothesis, indicating that the reliability is moderate but not ideal.
Regression analysis 4.1 Calculation of regression coefficient R-squared. Model summary. Null hypothesis. Independent variables do not significantly explain the variation in customer satisfactions. Alternative hypothesis. Independent variables significantly explain customer satisfaction. For R equal 0.436, moderate positive correlation between independent variables and customer satisfaction. R squared equal 0.190, 90% of the variation in customer satisfaction is explained by the independent variables. Adjusted R squared equal 0.149, slightly lower, indicating modest explanatory power of the model. STD error equal 0.64692, average predictions error in model. For ANOVA, null hypothesis, the regression model does not significantly explain the variation in customer satisfaction. Alternative hypothesis, the regression model significantly explains the variables in customer satisfaction. Regression sum of a square equal 5.787 indicates the variation in customer satisfaction explained by the independent variables. Residual sum of a square equal 24.692 reflects the variation not explained by the model. Total of some squares equal 30.478 represent the total variation in customer satisfactions. F equal 4.609. The F value indicates the ratio of the variance explained by the model to the unexplained variance. Coefficient. Hypothesis testing. Null hypothesis. Each independent variable does not have a significant effect on customer satisfaction. Alternative hypothesis. Each independent variable has a significant effect on customer satisfaction. Customer target. B equal minus 0.41. B equal 0.319. This variable has a negative but statistically insignificant impact on customer satisfaction as the p-value is greater than 0.05. Store location. B equal minus 0.293. P equal 0.236. This variable shows a negative relationship with customer satisfaction but is not statistically significant at the 0.5 level, marginal significance at p less than 0.1. Buying frequency. B equal minus 0.142, P equal 0.236. Similarly, this variable has a negative but statistically insignificant impact on customer satisfaction. 4.2 Multicollinearity test or coefficient. Tolerance indicates how much of the variability of independent variable is not explained by the other variables in the model. Customer target average 0.682. High tolerance indicate low multicollinearity. Store location average 0.666. Moderate tolerance but still acceptable. Buying frequencies average 0.759. High tolerance indicate low multicollinearity. Variance inflation factor VIF measure the extent of multicollinearity in the model values more than 10 indicates severe multicollinearity. Customer target average 1.279. No severe multicollinearity. Store location average 1.502, slightly higher but well within acceptable range. Buying frequency average 1.318, no severe multicollinearity. For this slide, Null hypothesis. There is not multicollinearity among the independent variables in the model. Alternative hypothesis. There is multicollinearity among the independent variables in the model.